Pinpoint asteroids in orbit, then hurl y'all thousands of miles an hour towards it.
In one of my recent uploads, I had a conversation with Witsit regarding flights in the southern hemisphere. You know, the ones they don't like to talk about anymore.
All right. Earth is life. What's up, B-Ball? Let me hear your home run here.
In that conversation, his arguments against these flights were that jet streams would make it possible for the aircraft to make the almost 13,000-mile journey across flat Earth in under 14 hours.
So yeah, you could definitely be in the south and go over 850, 900 miles an hour, right? And then still just be clocking like a 550 mile per hour airspeed, and you would cover an insane amount of land.
And also that the distance between two airports is somehow unknown and unattainable.
Hold on. The speed is verified by the website which posted it. Right? Then I can just take the time it took and the speed.
No,
and get the distance.
The speed requires the distance. The speed requires the distance, and that's
all right,
what
let me do this real quick.
So can you please verify the distance and speed?
Bro, just because we lived on Earth for thousands of years doesn't mean we know the distance between Johannesburg and Australia. You think ancient Rome knew that distance? I'm asking, how did we measure it?
Somebody does. Somebody does.
How did we measure it?
The FFA does.
How did they measure it? Good, I'm glad they know it. How did they measure it?
I'm sure that Witsit is aware, being the intelligent math whiz that he is, that the distance an object has traveled can be obtained simply by multiplying the object's speed by the time it took to get from point A to point B. Yeah, it's pretty bad when you have to deny things we learned in 5th grade math. Rather than just take Witsit's word for it, let's see if there are any other methods we can use to figure out the distance between places on Earth besides physically measuring it with a tape measure. So I scoured the internet for websites that would give me a distance between 2 points on Earth. And sure enough, there are a multitude of websites that do just that. Just input 2 cities or 2 latitude and longitude coordinates, and they all will tell you the approximate distance between them. So when utilizing the many resources on the internet to calculate the distance between latitude and longitude of 2 particular points, or 2 cities on Earth, Sydney and Johannesburg airports to be exact, they seem to always come out to roughly the same distance. Or we can just claim that the FAA, pilots, flight planners, or anyone for that matter, have absolutely no idea how to measure or calculate distances over the surface of the Earth, even though we as humans have been traveling and navigating the Earth's surface for thousands and thousands of years. You know what? Let's just say Witsit's right for a second. Let's say that jet streams actually did aid these flights. That would mean that every time this flight takes off, it's aided by an almost 500-mile-an-hour jet stream in both directions. That would also mean that the jet streams would have to literally change directions each time the flight takes off. Now, being the sane person that I am, and just using a little bit of common sense, you'd think that this 500-mile-an-hour jet stream in one specific direction would affect other flights as well, especially if it's traveling in the direction over the flat Earth that it would have to travel. That being said, flights coming in the opposite direction probably wouldn't make it too far since they're receiving a 500-mile-an-hour headwind. And any other flights moving through this jet stream would be blown wildly off course. Just something to think about next time you try and make this claim. Just hear me out, Witsit. I'm going to help you out so we can make this work on flat Earth. Now, Witsit, if you don't like that, let's break down the math just to make it a little bit clearer for you to understand. First, we have an almost 13,000 mile distance. Why 13,000 miles, you ask? Well, as I demonstrated in a previous video, if you laid a flat Earth flight path out on a globe, the distances covered over the land masses and the water come out to roughly that distance. Next, we have an aircraft that can travel about 550 miles per hour, which is its airspeed. And we have to cover this distance in under 14 hours. And just in case my friend Witsit doesn't understand what ground speed versus airspeed is, here's a simple to understand diagram. Ground speed is simply airspeed plus wind speed. So without a strong jet stream to help us along, our flight is going to take roughly 23 hours, which is 5 hours longer than the longest non-stop flight on record. The fastest reported jet stream on record was 260 miles per hour, which happened on February 9th, 2020, during a flight between New York and London. Now, if we add this record-setting 260 mile an hour jet stream to our 550 mile an hour flight speed, we get a ground speed of 810 miles per hour. This would result in a flight time of just over 16 hours, which is still 2 hours longer than a normal flight time of 14 hours between Sydney and Johannesburg. So in order to make this flight under 14 and a half hours, we need an almost 350 mile an hour jet stream added to our 550 mile an hour flight speed, bringing our total ground speed to 900 miles per hour. So there you go. A 350 mile an hour jet stream taking our 550 mile an hour aircraft to a total ground speed of 900 miles per hour, making our 13,000 mile trip in under 14 hours. This could totally work on flat Earth. But there's just one problem. Well, several problems. Problem number 1. QFA 63 travels from east to west, which by the way is fighting against the jet stream. So if you want to go with the jet stream, you're going to have to make this trip in under 11 hours. Let's see. 13,000 miles across flat Earth divided by 11 hours. That is, 1,181 miles per hour. That's how fast your 787 is going to have to go. Witsit, guess how fast your jet stream has to be? Yep, 631 miles per hour. Thanks for playing, bro. Problem number 2. As you stated before, the fastest jet stream on record happened in the Northern Hemisphere one time in history. The average speed of jet streams on any given day is between 80 and 140 miles per hour. Thanks for playing, bro. Problem number 3. According to NOAA and National Geographic, jet streams are strongest in the wintertime in the southern and northern hemisphere. Your claim that jet streams are faster in the southern hemisphere is just wrong. I'm not sure where you got that from. Maybe you thought wintertime only happens in the southern hemisphere? I don't know. Anyway, thanks for playing, bro. Problem number 4. Jet streams flow from west to east. So if it's blowing nearly 200 miles per hour in one direction, it's not just going to flip around and help the next flight going in the opposite direction. Thanks for playing, bro. And problem number 5. You might want to research what actually causes jet streams in the first place. And I know how you like citing things. So
you go to weather.gov. Right there, I dropped it.
One of the causes behind jet streams is actually the rotation of the Earth. So, thanks for playing, bro.
He goes to 24/7 flight radar, which takes the presupposed globe distance, then the duration, and then it just gives him the speed relative to what percentage of that presupposed distance has been covered. And it's just an algorithm that gives him the speed. And he thinks, oh, okay, well, this proves it. And it doesn't even give you the ground speed. So what you need to do to propose your claim, to even propose it, you need to get all the actual data from beginning to end, there and back, how long it took, how long it takes every time, what's the average, what's the variables that factor into that average, and how long it is for them to get to that place, and how many times it's actually faster or slower than the predicted arrival time. That's your first step. If you can't do that, you can't make any claims about how long it takes the plane to go. You don't even have how long it takes the plane to go.
So the cool thing about FlightAware, Flight Radar 24, and other websites is that you can download a spreadsheet showing every few minutes, it has flight time, it has the speed, it has GPS coordinates. So yes, I can get that data for you.
And to put the icing on the cake, for any of those flat earthers out there that are still clinging to the notion that these flights don't actually exist, here's a few examples of it actually existing.
So here we go, Qantas 64 coming in from Johannesburg. Next one to go, the 787-9 Dreamliner. She'll be making a very long flight over to South Africa, down to Johannesburg, Qantas Flight 63. This service formerly operated by 747-400s. As with most of the Qantas international destinations. I mentioned with another 787 on short final here. The Johannesburg, South Africa arrival.
Delta 573, contact departure today. 573 today.
Shout out now coming in from Earthy's Life. Shout out to the pilots of Qantas 63 and 64 for destroying flat Earth with every flight. Thanks for playing. Witsit gets it. That's it. Job and attend Earthy's Life. Well, that's appropriate for your call sign, isn't it? That's a long flight over there to Joburg and back. Huge shout out from you coming in with a big 10-0. So also passing on the shout out to the 63 and the 64 for destroying the flat Earth. The Earth is not flat.
Once again, thanks for watching. Don't forget to like, share, and subscribe if you like this video, and check out the rest of my videos if you're interested. And as always, peace.
Pinpoint asteroids in orbit, then hurl y'all thousands of miles an hour towards it.